Hello coders. In today's video, we'll see what are different Go's core collection types. Those are arrays, slices, and maps. We'll see how they differ from each other, how to declare each of them and use them separately, and what is the use case to use each of them. Let's get started. I'll get started by creating a file called slice.go. We'll have our package main, function main, and our formatting library fmt. Now let's assume you have a use case or a problem where you want to store marks for 10 students. Ideally, without collection types, what you'll do is you will have to initialize 10 variables with 10 different marks. Now that becomes cumbersome when you have a lot of students, let's say 50 or 100. That is the case where we use arrays. Now what are arrays? Arrays are a fixed list of similar data types. Now what do I mean by that is, let's get back to the same example where we wanted to store students marks for 10 students. Maybe I'll take 5 for easily managing it now. Marks is equal to square brackets. Square brackets indicates that you are going to define an array, and I will give 5. 5 here indicates the size of the array, that it can have 5 student marks at max. Now I'll define what kind of data your array will hold. Since it marks, I'll use it as int. And what are the marks it will hold? For that, you will need curly braces. The square brackets 5 defines the size, and it also lets the compiler know that we are reserving memory for a collection of items of data type int, and whatever is there in the curly braces will be a list. So for example, I can have 50, 60, 70, 80, and 90. So these 5 are your marks. Now let's go ahead and try to print it out for now, just simply just to have a look what it looks like. Go run slice.go. You see it is printed also inside square brackets, indicating that it is an array. Now let's say I want to access the third student mark, that is 1, 2, 3, 70. So what I'll try to do is I'll try and access third student, right? So now to access the third student, what you have to do is each array item has an index. As humans, what we'll think is, okay, 1, 2, 3, it is the third item. We can access the third index, right? But that's not how lists or arrays work in any programming language. The index of an element in an array always starts with 0. The index of 50 will be 0. This will be 1. This will be 2. This will be 3. And last will be 4. So the index will always be the length of array minus 1. Here the length of array is 5 and the last index is 4. What that means is, to access the third student's marks, we need to use the index as 2. Now, how do we use this index? To find the nth index element of an array, you have to use the array name and then use the square brackets and specify the index. So in our case, it will be 2, since we have to get the third student index 1, 2, 3, and this 2, right? So let's try and print it out. It is 70 and it is the third student marks. Now let's say I try to access an index which is not existing. Let's say for now I try and run 10. Let's see what happens. Yeah, you will see something called as index 10 out of bounds, 0 to 5. What this means is the index 10 does not exist in your marks list. In memory, what happens is when you try to assign a collection type, your compiler goes ahead and creates a contiguous block of memory for these particular number of elements. Now, when you try to access anything outside of it, it'll obviously return error. That's the error you see here, invalid argument. Right? Now, let's see how we can traverse the entire array at once. Let's say you want to calculate the sum of all the marks. Let's see, the marks is a 5 subject marks obtained by a student and you want to calculate the average. How do we do that? To traverse an array, there are two methods basically. One is a for loop that we have learned in one of our previous videos. Please do go check that out. Or you can use a keyword called as range. What range does is it will iterate from your first element to your last element in the list without the use of index. Now first let's see how we can do it with the traditional for loop. We have for I is a looping variable which we initialize it to 0. Why? Because to access the array element, we always need its index, right? We just saw before we had to write marks of 2 to get the third student index. Similarly, to access any element of an array, we need its index. We have for I equal to 0. Now, where should I go till? It will start from 0. It has to go till 4. Now, how did we arrive at 4? It is the length of array minus 1. There's a function called len in Go which calculates the length of the array. Now, if I have to give the array name here, marks minus, sorry, length of marks. I should be less than. So I'm using less than here. That means as soon as I becomes 5, 5 less than 5 will become false. That's the reason I'm using length of marks here. Maybe I can use length equal to here so that it's less confusing. I equal to 0 and I less than or equal to 4 and I plus plus. And I will try to print for now. Print marks of I. That is, for each iteration, I will print marks and in square brackets the index. So first loop, the value of I will be 0 and it will 50. And it will go ahead and increment. I will become 1. Then it will print 60. Again, it will go ahead until the length of marks minus 1. That is, length of marks is 5 minus 1, 4 until I becomes 4. Now, after I becomes 4, you will get printed 90. Post that I becomes 5. Again, your condition will be 5 less than 4, which is false, and it will exit out of the loop. Let's go ahead and run this. Yeah, you see each of the marks printed. Now, this is how you iterate over the list. What if, like I mentioned before, you wanted to calculate the average? So to calculate the average, what I'll do is I'll maintain a sum variable, which will basically in each iteration, it will keep on adding one of these marks to the sum. So initially sum will be 0. In the first iteration, what I want to do is I want to add sum plus marks of I. That means 0 initially when I is 0 and then marks of I will be 0, 0 plus marks of 0. Now marks of 0 is 50. So sum becomes 50 in the first loop. Similarly, it goes on for 5 iterations and in the end it will calculate the sum. Now once this loop is completed, let's try and print the sum. Yeah, you see 350 is the sum. Now to calculate the average, what we need to do is sum total number of marks by total number of subjects, length of marks. You'll get it as 70. Now that's how you calculate the average. So this is how you will use for loop to traverse an array using the indexes. Now let's see another method to traverse the same loop. This was one method, right? I'll comment it out for now. As I mentioned a little while ago, there is a keyword called range. Now what range does is range will iterate your list or traverse your list from your first element to your last element. How range works is range will give you the index, that is all the indexes that are available in your list instead of us having to manually calculate the index in our previous for loop. So for index in colon equal to range of marks, right? Here in this case, marks is your list and range is the keyword that is giving us the index for each item in your marks array. Now let's try and print it out. Marks of, maybe I can print index comma marks of index, right? Index is your all these indices in the marks array and marks of index will be the value of marks at index. Now let's try and run this. Declare or not use sum. Okay, I've not used sum. I'll comment it out. At zeroth index, it is 50, 160, 270, 380, 490. So that's what we expected. So it is functioning similar to the same for loop. Now, in this case, right, it is functioning similar to the for loop. So this might not be as useful, right, providing the range keyword. What range provides as an extra feature is it also provides the value at that index. So instead of index, if you use index comma value here, right, what you can have is instead of using marks of index, you can directly access the value. Now let's try and print this out. You see, you get the same output. So that's how range helps us. Now, in when we are trying to iterate over the marks array, we really don't need the index. We will mostly need the values. So in that case, as I've mentioned in one of my previous videos, you can always ignore the variable using the blank identifier. In this case, we will get only the value. So if you use only one particular return value that you are expecting from range, that will always be your index. If you expect two values from your range, that will be your key, index, and the value. You'll have to ignore the index and just get the value. Let's try and run this. You see all the values. So this was basically arrays and how it works. Now let's see what slices are. Slices are nothing but they are same as arrays, just that they don't have a defined size. Now let's say I have instead of marks, I have marks list, which is equal to array of int, and again I give the same values, right? So the both the declaration is same, except that your size is not defined. So if a slice is sorry, if the size is not defined, that means it's a slice in Go. And here you have defined size. So that's the first major difference. You can use both of them interchangeably as you want, but arrays are generally used where you have a fixed size limitation. For example, you want to define a vector. Vector has basically, let's say the vector is of 3 dimensions. So you can obviously define a vector something like this, right? Define it here. 3, let's say the XYZ value is 10, 15, and 20. This is where arrays come into picture. In most of the cases, when you're dealing with lists, you will have to deal with slices because you will not have any fixed size limitation, right? Rest all the traversal explanation that I've explained here remains same in the case of slices also, right? Now to just check, what I can do is I'll comment this out and try and execute it here for value in the range of marks list. I'll go ahead and run this. Oh, marks is not used. You see the output is same. So slices also perform the same way as arrays do. You can also access slices in the same way as arrays. That is, if you want to access the fifth element, marks list of, as I mentioned, indexing, it starts from 0. So for the fifth element, the index will be 4. Let's try run this. You have 90 at index 4. Now let's say you want to get only the sub part or the sub array from the array. That is, let's say you don't want the first and the last element of the array, you want only the middle 3 elements. In that case, what you can do is there is a syntax in Go where you can slice a slice. That is, from the marks list, I want, that is this element, that is your second index. That means 1, 2, 1, 2, 3, third element. So that is, you want 0, 1, 2, and 3 indexes. So I'll give 4. That's because when you're trying to slice and slice using the sub-array slice method, sub-array size syntax basically, the first index is included and the second index is excluded. That means you will have elements from index 1 to 3. That is 1, 2, and 3. Let's try and run this out. You see, you have 60, 70, and 80. This is even valid for arrays as well. So let's try, let's make this an array and then try it out. See, you have 60, 70, and 80. This is how you take out a sub array from your base array. Now let's say you want to exclude the first two elements and you want to have only the last three. In that case, what you can do is you can omit the last index and just give your starting index. That is your 2 because you want to exclude the first two. Let's try and run this out. So you have 70, 80, and 90. And in case you want to omit the last three out, in that case, you can omit the first index and you can have. So since you are excluding last three, you have to give the index as 2 because since 2 is not included by default, right? The last index is not included in the output. So it will have only 0 and 1. It will have only first two values. So this is how you slice an array or a slice. Now, just like I explained length of a list or a slice or an array, there is also a function called as cap, which tells you the capacity. Now, what does capacity mean? Capacity of a slice is the maximum number of elements it can hold without resizing the original slice. Now, for an array, the length and capacity is same because it is sized. That is, we always define the size of an array saying that it can hold only up to a maximum of 5 elements. Now, let's check this out. Length of marks list, and we have capacity, and the function name is cap of marks list. Right? Let's run this. And we have 5 and 5, and that is because since the slice is size, it is an array, and the array will always have the same length and capacity. Now let's try to create a slice with different capacity and length. Now to do that, or let's say you have a use case where you don't know what is the amount of data you will hold or the list of items that you will hold, and you want to dynamically provision some amount, a basic number of elements that you want to hold in a slice. In that case, how do you initialize a slice? For that, let's say I'll create a slice called values, and for that we use a function called as make. Now what does make do is make will initialize an amount of memory depending on the size you provide to it. For example, if I give make, it accept two parameters. One is the type of the data it will hold and the size. So we'll be creating a slice of type int and length 3. Let's try and print what this outputs. Length of values and capacity of values. Yeah, in this case, you see 3 and 3. So by default, when you give the length of 3, make will initialize a slice for you with length 3 and capacity 3. And we will also see what is the content of values initially. We'll directly print values. Here you'll see length is 3, capacity is 3, and the slice holds 3 elements with the default value of that data type. So in one of my previous videos, I had explained the default values for different data types. So for int, it is 0, and that's the reason you see 0 in the slice. Now let's see how we can create a slice with a different capacity. Okay, I'll modify this itself. What happens is, let's say the make also has an optional parameter, that is you can give the capacity additionally to the make function. So it will be type of your slice, then the length of your slice, and the max capacity it can hold. Now let's see how the output changes. If you see here, the length is still 3 and the capacity has changed to 5. That means in memory, it can allow or allocate more two values to the same value slice without resizing itself. And if you see here also, the length, since the length is 3, it has only 3 values assigned. The next two values are not there. Now let's try and add a value to a slice. Now to add a value to a slice, there is a function called as append. Now how does append works is, append takes in a slice where you want to add your value to and the value that you want to add. I'll add 100, and it will return a new slice with the updated elements. So I'll do values is equal to append values comma 100, and I'll print out the same values here. Okay, I can copy and paste. and run the output. Let's see how the output changes this time. Yeah, if you see here this time, the length is 3, capacity is 5, and the value was empty before. Now after appending, the capacity still remains same, but the length has increased because we have a new element here. Now let's try adding one more element to it. Let's say we add two more elements. We will add 200 and 300. If you see here, append can take multiple values. It is not just that it will take one, it can take many different values. So this is something called as variadic function. This we'll see in one of our upcoming videos, right? This I have not discussed in the functions video. We'll be covering it later. Now let's see what the output is and how the output changes. If you see here now, initially it was 3 and 5, then it became 4 and 5. Then when we assign two values, right, the capacity has doubled. Now it is not necessary that it will double. It can vary dynamically, but the length has become 6 and the capacity has also changed. So a resize in memory has happened because the initial capacity was not enough. Now that is how the Go runtime handles the addition of elements to a slice. Now let's see what are maps in Go. Now maps also behaves in kind of similar fashion, just that maps is a key value pair of lists. In arrays and slices, what we had is the keys were predefined and it cannot change. That is, you will have the array indexes from 0 and it will go to n minus 1. That is your number of elements in the list minus 1. They were fixed and we did not have any option to modify those. So maps are a special type of slices where we can say where the keys are custom defined by the programmer. Now, how do we define that? Let's say I have students. Now to define a map, the keyword is map and the syntax is we define what is the type of key it will hold. It can have integer, it can have string, you can have any data type, basic data type that is supported by Go. So we can have int and then what is the type of value it will hold. For now, I will keep it int only so that we can compare it with slices. And again, just like slices, we need to define what are the values it will hold using the curly braces. Now, to define what are the values, let's say at 0 index, I will have. Now, colon is to define what will be the value in the sense, and each line will say what is the key colon value. And my value for now, let's say 50 and comma. Now, this becomes one entry in your map. Now this is same as a slice which has one element at index 0 and the element value is 50. Similarly, we can have 1 colon 100. Now it is not necessary that they have to be continuous also. Let's say I can take 100 also here and I can give the value 1000. Now this is a map. Now to iterate over map, again the same for loop we can use. Either we can use the range with key value or range just with the key. Now we'll try with the key for key equal to range of students. Now in the case of slices, your range keyword will give you index. Here also it will give you the index, but in the form of index you have keys. So keys will be 0, 1 and 100. And to print it out, you have key. And again to access the value, it is similar to slice where you have square brackets and the index. Here key. Let's run the program. Maybe I can comment these out so that it's more clear and I'll run it again. You see 0, 50, 100, 100, 1000. So this is the key and the value. Again, similarly, in the range, we have both key value access. So we can use the key value also. We'll get the same output, right? Now, if you want to add an element in the map, how do we do that is in name of the map, square brackets, and since it is integer, we will have a new key here. For example, I want to add at index or maybe at key 2 a value equal to 200. Now this is how you add a new value to a map. Now let's try printing it. You see, earlier we had only 3 items. Now we have 4 items in the map. Now, how do you delete an item from the map? For that, there is a keyword or a function called as delete in Go, which will take your map as an input and the key to delete. So here in this case, let's say we try to delete the key 100. In that case, just give 100. Now let's see what happens with the map. For now, I'll give fmt.println to identify. This is after delete. This is after insert. Right? Let's try and run. You see, initially it was 3 elements, 100, 100,000 and 050. After insert, it has become 4 elements. And after delete, it has become 3 elements. You see, the 100 key has been deleted. Now let's see what happens when you try to delete a key that is non-existent. I'll remove this for now and I'll delete students, comma 2, which does not exist, and print the map directly. You see the map is printed directly with all the keys existing. So even if you try to delete a key which does not exist, it will not give you any error. Let's see if we want to add a value based on if the value exists for that particular key or not. What I mean by that is, let's say maybe I'll take a different map, right? Here in this case, I'll take students colon equal to map of string. I will have string keys and I'll store the marks of the student. In this case, I'll take John as the name. So here your key is a string. That's why it's double quoted. And then the value is, let's say 70. And we have one more name Helen and we have 80. Now in this case, let's say I want to check if the student John has a mark. For that, what we can do is students of John, right? Keys are case sensitive. That is because strings are also case sensitive. When you compare two strings, it has to be exactly same, case to case, right? So students of John equal to 90. Now what happens in this case is whatever value is there in John here, 70, will get updated to 90. Let's check it out by printing it. Go run slice.go and you have Helen 80, John 90 because we have assigned it 90. Now let's say I want to get the value of John. In that case, what do? I will take value colon equal to, that is for you to define a variable, and then students of John, right? And I'll print the value. You see, you get 90. Now, let's say I try to get a value for a non-existent student. I'll keep the student name as Foo, for example. Let's see what happens. You get 0. That is because by default, when you try to access a key which is non-existent, the map will return the default value for that particular type. Now, what I mean by that is here our type is string to int. So when you try to access any non-existent key, it will always give you the default value of int. So by default, the default value of int is 0. That's the reason you get 0. Also, there is one more method where you can check if a key exists in your student map or not. Instead of just getting the value, just like range, when we try to destructure a map, we get two values. One is the actual value and a Boolean value indicating whether that key exists or not. Now, when I try to print that, you should get the value of OK. For now, I'll take it as exists. The value of exist should be false because it does not exist. See, false. Now let's try to access John again. In this case, value will be 90 as we have seen before, and exist will be true because the key exists. 90 and true. So that's how maps work in Go. You can also calculate the length of a map using your len function, that is len of students. This will give you the total number of entries in your student map. I'll remove this and run. You have 2. That's because you have 2 entries. Just like you initialize slices with make, you can also initialize map using the make function. So let's see how we can do that. It's equal to make the type that is string to int, since that's what we took in our example. You can actually give a length here, but it will not make any sense to give the length here because the length of map will automatically be adjusted when you add and delete items in your map in the memory. Now we have map, and to assign values, we can do students of, let's say, John equal to 80 and students of, let's say, Paul is 90. And again, we can print it out, students. Let's try to run this. We have map of John 80 and Paul 90. So that was all about maps, slices, and arrays in Go. If you have any questions or doubts, please let me know in the comments. On that note, this is Cron Coder signing off. See you on the next one.